All right, so in this video, I'm going to go through sample question 5 from the Society of Actuaries ExamP list of sample questions. All right, so this is a good question to try yourself if you haven't done so already, and then obviously come back to watch this video. All right, now I remember this question fairly well in terms of it was the first question that really I got stuck on. You know, it's a very weird question to give you a lot here. So don't feel too bad if this question gives you trouble. It's kind of weird. So the question reads, an auto insurance company has 10,000 policyholders. Each policyholder can be classified as young or old, male or female, married or single, right? And obviously these things are like mutually exclusive and complements, right? You can't be young and old. Like if you're not young, you must be old, right? And you can't be like married and single at the same time. Although some people try to pretend they are. Of these policyholders, 3,000 are young, 4,600 are male, 7,000 are married. The policyholders can also be classified as 1,300 young males, 3,010 married males, 1,400 married young persons. Finally, 600 of the policyholders are young married males. The question asked, finally, calculate the number of the company's policyholders who are young, female, and single, which now reading this again sounds more like an eHarmony dating profile than a math question, but let's not pay attention to that for now. So I apologize if I sound like your old high school or college physics teacher, but let's write our givens to start with, right? What does the question say? Because there's a lot here, and we just want to get out the important bits. So it says 3,000 people are young, which I'll use for y. Y is equal to 3,000, right? And like I mentioned before, if you're not young, you must then fall into the category of old. And since there's a total of 10,000 policyholders, that means 7,000 of them must be old. So whether they know or not, each of those pieces of information doesn't give us one, but gives us two things that we know about all our policyholders, right? Or gives us two things rather than just the one they're explicitly stating. It says 4,600 are male, so I'm going to use M for male. That's 4,600. So that means those that are female would be 5,400. Okay. And finally, it says 7,000 are married, and I'll use MA for married. What was it, 7,000 said? Yeah, 7,000 are married. Gives us how many are single? That is 3,000. And then it gives us even more information. So policyholders can be classified as young males. How many are young males? Well, there is, so young and male, well, there's 1,320 of them. And then how many are married males? So that's your male and your married. Well, that's 3,010 of them. And 1,400 are young married persons. So you're young and you're married equals 1,400. Finally, 600 of the policyholders are young married males. 600 are young and male and married. 600. And that's all the information we're given, right? Just a weird amount. And what is it asking us to find? This particular number, young and female and single. Okay, or just the S. So how do you even go about this? Well, let's see here. The same way we got this other information, we can use this information to kind of extract other categories, right? Other classifications of policyholders. So of those that are young male, that means in our group of male, in our group of young, right, of the 3,000 young people, 1,320 are male. Therefore, if you're young and female, that would be the rest of the young people, right? So that would be obviously 3,000. I'm going to use a calculator just to not make an embarrassing simple math mistake. Minus 1320. And that gets us 1,680 people are young and female. Okay? Now we got these group of young females, and some of them are married and some of them are single, and we kind of want to figure out which is which. So here is our, here's a way to do that. Okay? So we know that 1,400 people are young and married. Okay, so if I were to draw that out, let's say here is my total group of people that are young and married. Young and married. Now this group is split up into people that are male and people that are female. Now, we're told as our last thing, 600 people are young, married, and male. So that means there's 600 people, I can write that weird, 600 people in this group. Okay, meaning how many are there in this group? Well, if this is supposedly equal to 1,400, supposedly, like this is actually equal to 1,400, that means this must equal 800. Okay, so we have young and married and female equal to 800. Now, here's the last bit of information we need. And this is why this is a weird problem. It's not like I'm doing this, I'm doing it in a systematic way, but it's not like I've seen this exact type of thing before, right? So let's now visualize, right? Drawing diagrams and pictures always helps. Let's now visualize everyone that's young and female. So young and female, right? Earlier, we found that number to be 1,680, right? 1,680. Now, if you're young and female, according to our classifications, you're either married or you're single. Now, we figured out young married females, right? Young married females. That's 800 of them. 800 of our policyholders fall into that category. That means in this box, there should be 880 left that are young, single females, which is exactly what our question is asking us to find. So the answer is 880. Okay, so this question is kind of a bit confusing. You're jumping from one thing to another. What you need to know, and this question is really testing general probability, really kind of basic stuff, but in kind of a more complex kind of question as some of the others. So what you do need to know is that when you have a sample space made up of two sets, right? Set A and the complement of A, that's supposed to equal the entire sample space, right? That's how I'm able to figure out who's young and old, although I don't think I necessarily used any of that information. I might have needed it. So another thing that's really important is how good visuals are with helping solve a problem. Always try to draw a diagram if it's applicable to the question. It might seem like it takes longer, but the act of doing a diagram will make it easier on you, thereby making the question go a lot quicker. Okay, hopefully I cleared up question 5. If there are any questions you have left on how to solve a problem like this, or even solving this specific problem, leave them down in the comments. I'll answer them as best I can. Okay. If you want to check out some other videos, I have other questions. I go through some other questions. If this video helped you out, definitely hit the like button. That totally helps me out. But other than that, good luck, guys.